To begin with this chapter, let's define some terms first. Let's define a random variable. A random variable is a function that associates a real number with each element in the sample space. We shall use a capital letter, say capital X, to denote a random variable and its corresponding small letter, small x in this case, for one of its values called the mass points. Let's say, for example, in a random experiment of tossing two coins, what will be the possible values of capital X if capital X will be the number of heads obtained? By this example, capital X will have four outcomes. From tossing two coins, you have head-head, head-tail, tail-head, and tail-tail. Then you will have to count the number of heads per outcome. For the first outcome HH, you have two heads. For the second outcome HT, you have one head. For the third outcome TH, you have one head also. And finally, for the last outcome tail-tail, you have zero head. Therefore, the mass points small x will be 0, 1, and 2. Now we are going to classify the two types of random variable. First is the discrete random variable. A discrete random variable is a random variable that could take only a finite or a countable number of possible values, while a continuous random variable is a random variable that takes on an uncountable number of values from a given finite or infinite set of values. So let's say you have here a table showing an experiment, its corresponding random variable x, and we will have to identify its mass points and classify whether it's discrete or continuous. The first experiment will be inspecting 20 deliveries of cellular phones. Note here that the random variable x is the number of defective cellular phones. Therefore, the mass points for this experiment will be 0, 1 until 20. And how will you going to classify it? It will be discrete. For the second experiment, getting some rice from a 20 kilogram sack. The random variable x for this example is the weight of rice in kilograms. Therefore, the mass points will be, if expressed in terms of inequality notation, x could be between 0 and 20 inclusively. Therefore, since we are talking about weight, this will be a continuous random variable. Our lesson will only focus on discrete random variable. And to begin with this topic, let's discuss probability distribution of a discrete random variable. The probability distribution of a random variable designates probabilities to the possible values of a random variable. For a discrete random variable, the probability distribution is defined by the probability mass function denoted by the probability of big X equal to small x. The probability mass function is a table, formula, or graph showing the possible values of a random variable together with their corresponding probabilities. The possible values of the random variable are called mass points, as discussed earlier. Let's say, for example, consider the experiment of tossing a die. Let the random variable big X be defined as the number of dots shown on the upturned face of a die. Construct a probability mass function. A fair die is thrown infinitely many times, with the random variable big X equal to the number of spots on any throw. The probability mass function, or PMF, of big X can be expressed in three ways. By a table, formula, or graph. We'll have to begin with expressing the PMF by a table. The tabular form of PMF has two rows, the mass points and its corresponding probabilities. For this problem, your mass points will be from 1 to 6, and therefore, each of these mass points will have 1/6 chance of occurring, so we'll have to fill in 1/6 per outcome. Now you're done with expressing PMF by a table. We'll have to express PMF by a formula. The formula for the PMF is expressed using a piecewise defined function. The left-hand side should always be the probability of big X equal to small x, and we will enclose it in a bracket, a French curly bracket, for its right-hand side, which corresponds to the corresponding probabilities. The probability is 1/6 if x is equal to 1, 2, 3, 4, 5, or 6. And the probability is 0 otherwise. And in order for you to express the PMF using a graph, it will always be a histogram. The x-axis of the PMF is always the mass points, 1, 2, 3, 4, 5, 6. Since you only have one value for the probability, which is 1/6, they will all have the same heights for this histogram.
As said in the outline earlier, we will begin with the definition of terms. We'll begin with defining statistics. Statistics is a collection of methods for planning experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on data. So this is a diagram showing the different processes involved in statistics. Note that the statistics follows a scientific method. Thus, it shall begin with the following steps. First is data collection, followed by data organization, then data analysis, drawing conclusion, and data presentation.